Okay, so question number 6 says to talk about the SN1 reaction. Okay, so the SN1 reaction is also known as the nucleophilic substitution reaction. And basically, the rate determining step involves one component, which is why they call it SN1. And typically it takes place in 2 steps. Okay, so I'll just show these 2 steps now. So the first step is when we have our reactant. So let's say we had a bromine attached to this carbon, this tertiary carbon group. And the first step is the loss of our leaving group, which is bromine. Okay, so after bromine leaves, we get this positively charged carbon group like this, called a carbocation. So this brings us to the second step, which is called the nucleophilic attack. So this is when our nucleophile comes in and stabilizes that positive charge or neutralizes it. And our final product now has a chlorine group. So that can be any nucleophile, but I just used chlorine for the example. And the loss of our leaving group is known as the rate determining step. So there are different factors that can tell us when an SN1 reaction may occur. So typically, SN1 reactions occurs with a hindered electrophile. And if there's any potential for resonance stability. So in our case, stability. So in our case, we have a tertiary carbon, which is pretty good at stabilizing this positive charge for the carbocation intermediate. So I'll say for resonance stabilized carbocation. And typically, our nucleophile can be uncharged, and it might take place when we have a protic solvent. Okay, so the junior tutor said that the SN1 reaction is a nucleophilic substitution in which the rate determining step involves one component. They have one nucleophile substitutes the other via the formation of a positively charged intermediate. These reactions take place in 2 steps. In the first step, the leaving group departs with a shared pair of electrons, forming an intermediate, and the attack of the incoming nucleophile takes place in the second step to form a substitution product. Okay, so here's their reaction. They are unimolecular. They give a racemization of stereochemistry at the reaction center. Neighboring group participation in SN1 reactions can be important. So they also have the mechanism, and they break down the two steps again. And the rate depends on both the ability of the solvent to keep opposite charges separated and its ability to stabilize both positive and negative sites by solvation. Okay, so this solution is correct.